Episode 10, DAX Fundamentals. 8 AtlasParts tables loaded, 4 of them connected through a clean star schema, and a calendar table marked as the date dimension. Time to write our first measures. DAX is the language Power BI uses to calculate things. Looks a lot like Excel formulas at first glance. Then filter context shows up, and that resemblance stops being helpful. Five ideas to land today, in order. Where a calculation lives. Your first measure on the journal. The concept that makes DAX hard, which is filter context. Calculate, the function for modifying that context. And finally, SUMX and VAR, for measures that need to do real work. By the end, you'll have 4 working measures sitting on AtlasParts cards, and DAX will start to feel like a real language instead of a dialect of Excel. DAX gives every expression 2 homes, a calculated column or a measure. They look identical in the formula bar. They evaluate at completely different times. A calculated column runs once at refresh. It adds a new column to the table, computed row by row, and stored in Vertipaq alongside the original data. A measure runs every time a visual asks for it. No new column is created. The formula is recalculated under whatever filter context the user has applied. Rule of thumb. If the value depends on context, like a slicer or a date range, make it a measure. If it's intrinsic to the row, like a status label, a calculated column is fine. Finance models lean heavily toward measures. The simplest possible measure is a sum. Right-click the journal table, choose New Measure, and type one line. Total debits equals sum of debit amount. Drop the measure on a card visual. You'll see a number in the millions, the grand total, across every row of the journal. Now drag a slicer for region onto the page. The moment you click a region, the card updates. Same measure, different number. No code changed. That's the magic of DAX. Write the measure once. It adapts to wherever it lands. A pivot table in Excel does something similar, but a pivot is tied to one source and one layout. A DAX measure works in any visual, against any slicer combination. When a card displays total debits, the visual is asking DAX a question. The question isn't what the measure computes. DAX already knows that. The question is, compute it under these filters. The filters come from everywhere. Slicers the user clicked. Rows or columns of a matrix. Cross-filtering when someone clicks a bar in another chart. Page filters, report filters. All of those combine into one thing called the filter context, and that's what DAX evaluates against. Here's the model. Every measure runs in a filter context. The context narrows every table down to the matching rows. Then the measure does its arithmetic on what's left. When you click a region, the customer's table is filtered. The relationship to the journal propagates the filter. The fact table narrows. The sum runs on the survivors. The cart updates. This is why the star schema we built last episode matters so much. Without those relationships, the filter would never reach the journal, and the visual would silently show the unfiltered total. Eventually, you'll want a measure that ignores the user's filter or applies a different one. Year-to-date revenue, regardless of the date selected. Same-store comparisons that aren't driven by what the slicer says. Percent of total measures. Calculate is the function for that. It modifies filter context. Its first argument is an expression to evaluate. Everything after that is a filter to add, remove, or replace. First pattern, adding a filter. Revenue from new customers equals calculate of total revenue, with customers as _new equals y. Take the existing context. Add the filter on top. Evaluate the measure under the combination. Second pattern, removing filters. The ALL function on customers strips every filter from that table, no matter what the slicer says. Useful for percent of total. Divide the filtered measure by the unfiltered one. Calculate is the most used function in DAX once you're past basic sums. Most non-trivial measures involve a calculate somewhere, because most non-trivial measures need to modify filter context. Sometimes the column you want to sum doesn't exist yet. Suppose AtlasParts has a sales line table with quantity and unit price as separate columns, and you want total revenue. The naive approach is a calculated column for revenue, then sum it. It works. It also stores a brand new column in Vertipaq on every row of the fact. The better approach is an iterator. SUMX walks every row, computes an expression for each, sums the results. Nothing is stored. Here's the model. SUMX of sales order lines, quantity times unit price. Row 1, 12 times 24.50. Row 2, 4 times 189. And so on. Each product computed at query time, summed, returned. The X suffix family includes AVER, AGEX, MAXX, MINX, COUNTX, RANKX. Use them when the calculation needs to happen row by row before the aggregation. Plain sum and average work when the column already exists. A common rookie mistake is writing sum of quantity times unit price and getting a syntax error. Sum takes a single column reference, not an expression. You need SUMX for the row-wise calculation. A measure with 3 calculate blocks and a divide by 0 check is hard to read in one line. DAX has a clean way to split it, the VAR and return block. Each VAR computes a value and binds it to a name. Revenue, cost, margin. Then return gives back the final expression, divide of margin by revenue, with 0 as the safe fallback. Variables are evaluated once, even if a measure references them 3 times. So the savings are real, not just stylistic. Variables also help with debugging. If a measure is wrong, comment out the return and return one of the variables instead. You'll see the intermediate value directly in your visuals. Put the original return back when the value matches what you expect. Use variables freely. Any measure with more than 3 lines is clearer with VAR. By the end of this episode, you should have 4 working measures on AtlasParts. Total debits and total credits, straight sums, net movement, the difference between them, and revenue from new customers, your first calculate. Drop any of them on a card. Drop a slicer next to it. Watch the number react correctly to whatever the user clicks. Next time, time intelligence. Year to date, prior year, month over month. The questions every finance team gets asked every Monday morning. The calendar table from episode 9 finally pays off. Episode 11, Time Intelligence, Year to Date, Prior Year, Month Over Month Variance. The Monday morning questions finally in DAX. Download the AtlasParts dataset and the Episode 10 starter file. Link in the description.